Welcome to Module 3, Lesson 23, the volume of a right prism. Now, we've been talking about right prisms, actually, in preceding lessons, and we will get a little further into right prisms, because now we were talking about volume. What we've been actually concerned with beforehand was the surface area, okay, which is of course, the outside surface. Remember, I asked you to think about it as if we were going to paint an object. All of the surface that we could slap that paint on, that would be our surface area, okay? Alrighty, and just a little bit more about area versus volume. Area is a measure in two dimensions, and again, what I just mentioned, height and base. Again, if you're going to paint a wall in your house, you would measure the height times the base, and you would take that measurement, which would be in square units, and you would get enough paint, for example, to cover that area. And if you look at a can of paint, you can see that its coverage is often included somewhere on the label, and it tells you how much estimated square footage or square meters that a can of paint could actually cover. Okay, and again, I say estimated because sometimes some people will just do it in one coat, and some paint is better for that. But sometimes you have to have two coats, which means that you would, if you're going to use two coats, you'd get half of that measurement. But anyway, an estimated measure there. Okay, so a measure in two dimensions is area. And of course, a volume, and again, I know a lot of you have talked about volume in the past, and we talk about it in science a lot, very similar measurement, but yes, volume is a measure in three dimensions. Okay, our world, the world around us, is in three dimensions. We all have volume. Everything in this world has volume. Every object, all matter has volume. Even the air that we breathe around us has volume, simply because, we'll get to that in a minute. Okay, so I want to ask you, so the area we've been talking about in this, previously was surface area. Okay, and then volume. The amount of space an object takes up. Okay, that is the definition of volume. I want you to think about mathematically as well as scientifically. Whenever you enter a science class, volume is all about the amount of space an object takes up. So in terms of volume, in the room around you right now, the thing that takes up the most volume in your room is air. Okay, very difficult to measure, truly, but it is around you. It's volume. But every three-dimensional, anything, everything's three-dimensional in our world, truly. Even a piece of paper, which you think is so flat and paper thin, also has volume because it takes up space. Okay, so, I didn't want that one part to happen so quickly. Let me go back and do this. Oh man, there we go. Hold on a second. Sorry. There we go. Okay. So our opening exercise here asks us, or tells us here, the volume of a solid is a quantity given by the number of unit cubes needed to fill the solid. Okay, so most solids, rocks, baseballs, people, just talked about this idea, cannot be filled with unit cubes or assembled from cubes. Okay, though the Lego people would have it otherwise. Yet such solids still have volume. Fortunately, we do not need to assemble solids from unit cubes in order to calculate their volume. One of the first interesting examples of a solid that cannot be assembled from cubes but whose volume can still be calculated from a formula is a right rectangular prism. Okay, a right rectangular prism. So, first question, what is the area of the square pictured on the right. We're going to start from area, and there we go. We see it happening. Okay. Yeah, area we calculate by base times height, which is 6. In this case, 6 times 6, which is 36 units squared, 36 square units. And they are square units because each one of those is 1 by 1, 1 unit by 1 unit. So there are 36 of those in that picture. Okay, 36 square units. Okay, next. Next, we're asked to draw the diagonal joining the two given points. You see those two, well, they're red on my sheet here. They're probably just two kind of black or gray dots on your page. Okay, draw the diagonal joining the two given points, then darken the grid lines within the lower triangular region. So if we go ahead and draw that line joining those two given points, and go ahead and darken in those lines. Okay, so now we can see we have actually we've actually split that figure in half. So the question here would be, what is the area of that triangular region? Now, if you would like to go ahead and write your answer down, I'm sure many of you know, because indeed it is it's probably a bit of common sense, but let's just go ahead and further explain it and look at it a little bit further. Okay, so yeah, that of course that area, I mean, is going to be 18 square units. Okay, how do we get that 18 square units? Well, we can add up all of the full squares, and if we add up all of those full squares, then we have then we add up all of the half squares. Okay, so we have 6 half squares, and then we just do that multiplication, 6 times 1/2, and that equals 3. We originally had the 15 whole squares plus the 3 other squares that were assembled from the half squares. We get 18 square units. So we can look at that, you know, very literally, and we could also think of it as, well, I just cut this thing in half. Of course, it's going to be half of my original square, which was 36 square units, so it's 18 square units. Okay. Now the question is, how do the areas of these two compare? And of course, like we just mentioned, you know, that one, the 18 unit square, this triangular shape right here is actually half of the original square from which it came. Okay. All right, so here, exploratory challenge, the volume of a right prism. So now we have added a dimension, okay, because before we were talking in 2 dimensions, therefore we had units squared. Now we are talking about, and I need to go back because that's not what I wanted to have happen. Sorry, get rid of all that. Oh man, I tell you. So, oh geez. Oy, oy, oy. Here we go. No, back. Sorry. Okay. Yeah. So what is the volume of the right prism pictured on the right? I'm telling you already, it's 36 cubic units, okay, or units cubed. All right. How do we get that? I should have asked you to do it yourself first, but that's okay. You'll have lots of time to practice this on your own. This is a teaching video. So here we go. Let's go ahead and take a look at it a little more closely. How do we get that? Okay. Oh, geez, don't want to do that. You know, I think I missed the whole first part. So I'm going to start all over again here. I'm going to do that. Here we go. And then that. There we go. Next step. There we go. I mean, the very basic and simple way to do that is just to go ahead and add up all of these cubes, because they are cubes, because they are 3-dimensional. Okay, we have 36 cubes. All right, so we have 36 cubic units, or units cubed. Okay, and the way we get this in terms of a formula is we have 3 dimensions, so we're going to multiply those 3 dimensions. We have 6 going this way. We have 6 that way, so base times height. And now we have a third dimension, which I'm calling here width, or not width, but depth. Okay, depth. We're not going to talk about it as depth throughout this lesson. Actually, it's going to be given another term, which is height. Okay, which is kind of confusing in the sense that we've been used to using the other dimension as height. But anyway, we have 3 dimensions, and that's what's really important. Okay, we have one level of these cubes, a 6 by 6 array assortment of cubes. Okay, so we have 36. Okay, now if we go ahead and draw the same diagonal on the square base as done above, we did before, and then darken in the grid lines on the lower right triangular prism, what is the volume of that right triangular prism? If you can just guess first, I'm sure you'll have a very good idea of what that is going to be. But let's go ahead and take a look at it and explain it in the meantime. Get rid of all that. Okay, so we know the first. This rectangular prism, or the square prism actually, was 36 cubic units. But then if we cut this thing in half, just like that, okay, all right, very similar to what we did before, but we were in 2 dimensions then. Now we are in 3 dimensions, okay. All right, and then we have 18 cubic units, which you probably guessed, but how do we get that? Okay, so first, like we did before, we count our whole cubes, and all of those are those are whole cubes. We have 15 whole cubes, and we have 6 half cubes, which is equal to 3 whole cubes. Therefore, we have 18 cubes, total cubes, in that picture right now, in that right rectangular prism, which is we denote as 18 cubic units. Okay. All right, so next we are asked here, so how would we create a right rectangular prism with 5 times the volume of the right rectangular prism pictured to the right, which is the exact same right rectangular prism we just worked with, okay? Now we don't want to change the base, and this is really important, okay? Without changing the base, draw your solution on the diagram, okay? This is not too easy to do, I have to tell you, and I would highly recommend maybe using some grid paper if you're going to work with this. And if you're not interested in drawing at all, don't worry about drawing a perfect picture, okay? But if you draw the solution on the diagram, give the volume of the solid, and explain why your solution has 5 times the volume of the original triangular prism, okay, of this one right here. Okay, so go ahead and give that a whirl and come on back. Okay, so let's go ahead and look at it. So I start with my original right triangular prism. There we go. And now I have another layer. So I have layers or levels of this. And I want to make something that's 5 times as big. So I need 5 layers or 5 levels. Now I had no magic program solution here to actually stack these all on top of each other, but you can imagine what they would look like if we stack them all on top of each other, squish them all together. Okay, so there's one level, and that one level, and we have 5 levels here. Okay, so we have 5 levels of that same right rectangular prism. And that one level rectangular right triangular prism, excuse me if I said rectangular just before, but I get all kind of messed up here sometimes. So yeah, that one level right there was 18 cubic units. So just imagine if you have 5 levels of that, squish them all together, okay, you have 5 times that 18 cubic units. Therefore you have 90 cubic units in our new right rectangular prism, which doesn't look like a right rectangular prism because they are separated, but if we squished all of these together, so this on top of that, on top of that, on top of that, on top of that, okay? You can imagine what that would look like. And maybe you've drawn something just like that. Okay. All right, so now what could we do to cut the volume of the right triangular prism pictured on the right in half without changing the base? So now instead of multiplying it by 5, making it 5 times the volume, we are trying to cut the volume in half. So draw your solution on the diagram, give the volume of the solid, and explain why your solution has half the volume of the given triangular prism. Go ahead and give that a whirl and give it a try and come on back. Okay, so welcome back. Let's go ahead and go through this. Okay, so here is our original right rectangular prism, okay? And if we went and cut it in half, and again, they had asked you, without changing the base, which was really important. So we haven't changed the base at all, but what we've done is we've just cut a line, cut them right in half. Imagine we had some sort of saw. We could just nice, beautiful half. Mine isn't as beautiful, but you can see now I have a level of yellow, and then the level of white as well. So we've cut this in half. Okay. So originally we had 1 unit high, or 1 unit of height, but now we have a half a unit of height. Okay. So the volume of the new prism equals 9. Oh, should be units cubed. Excuse me. Is 9 units cubed. Okay, so we have 9 units cubed right now, when originally we had, of course, 18 units cubed. Now, here's an important note. I just want to let you know, and we'll talk more about it in the future. But the prism's volume was cut in half because only one dimension was halved. Okay, in this case, we've only cut its height in half. Okay, so we've only cut its height in half, and that was a 1 unit. Now we're down to half a unit. And again, I don't want to confuse you here, but in the future, if you're going to cut this thing, and let's say we're doing scale, if you were going to actually cut all these dimensions in half, for example, instead of a 1 by 6 by 6, it was a half by 3 by 3, you would need to actually cut that original volume in half by half by half. So it would go from 18 to 9 to 4.5 to 2.25. Okay, so and again, I'm not going to get into too much about that, but really, really important note. It's not just it's not acceptable to just use that half if you're using more than one dimension. In our case, we only had one dimension was halved, therefore it became a half of the original volume. Okay. Okay, so now we're looking for a basic formula for the volume of any right prism. Okay, so let's look at a right prism here. Here we go. We have a right prism. Area of base, okay, is the first thing we need. And that area, in this case, of this base is 36 units squared. Very, very important that we have square units when we're talking about the area of a base. Okay, it's the area of the base. Now the base, we have made this this rectangle or this square. Okay, and we'll talk more about the importance of determining what exactly the base is. Okay, and then we're going to multiply that area by the height of the figure, of the solid. And in this case, you can see the height is 1 unit. Okay, it's 1 unit high. You can see this is a very lame arrow right here. So we're just measuring the height. Okay, that's 1 unit high. That's 1 unit, and we get a total of 36 cubic units. Really important, and again, we'll talk more about this in the future. When you multiply anything units squared by units, you notice that you get units cubed. Okay, it's a very, very important rule when it comes to multiplying exponents, which these are. You know, this square and this 3 up here, this cubed. Those are exponents, and if you haven't heard of that yet, don't worry about it. If you have, I'm very happy. I'm hoping most people have, but very, very important rule, and I'm not going to talk about it now, but you might be able to deduce what it is when you multiply exponents. What happens with the answer? Okay, and of course this is unit, and that would be a 1. We never use that 1, but that's what it would be. Okay, all right. And the area of the base. Here we go. Okay, so here is an example: the volume of a right triangular prism. So find the volume of the right triangular prism shown in the diagram using our new formula: V equals B times H. Okay, and I want to make very, very clear that that B is the area. Did I not finish that word? The area of base. Okay, it's the area of the base. It's not just this measurement here, for example. Okay, it's not just the 4, because that is the base as well, but it is the area of the base. Okay, so I'd like you to go ahead and give it a whirl, give it a try, use what we've done already to help you out, and then come on back and check it with me. All right, so here we are. We are back. Okay. Yes, we have the area of the base. Oh, I finished that E there. I'm sorry. Okay. And yes, so step number 1. Step number 1, we need to figure out our base, or the area of our base. Okay, the area of our base. And in this case, our base is 1/2 4 times 1/2. And where do we get that from? Where do we get that from? Well, we get that from this right here. We can see this is our base right there. Oh, maybe I did. Did I draw that already? No, hold on a second. I'm sorry. Here we go again, doing that thing again. Boom, 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 boom. Okay. Okay, so I'm not sure if I did this already, but just want to show you a little more closely. But here's the base. We've decided, and again for a very good reason, that this is our base. There is our base right there. Okay, our base is the triangle. And again, if you remember from way back when, all prisms bases take. The prism takes its name from its base, if you remember. And in this case, we have a triangular prism. Therefore, the triangle is its base. Now, we often think of base as something something stands on. Okay, the base is at the bottom. And in this case, I mean, it should be, really. So you have to imagine, you have to be careful when you're looking at something like this, and you don't just assume that the base is the bottom part, okay, which would be this, this square right here, okay, because it's not, well, it's not a square, it's a rectangle, but it's not that, okay. The triangular prism is going to have the base as the triangle, okay. So, and again, we know the area of any triangle is 1/2 base times height, and that's exactly what we just did right here, okay, and we came up with 1 meter squared as the area of our base there. And I hope that makes sense. Really, really important distinction, though, and we'll talk about that again when we close. Okay. All right. So, there I just explained it right there. Okay. So there is the base. We figured that out, and now we need height. Okay, and the height is that 6.5 meters. It sure doesn't look like height on this diagram because we don't usually measure height flat on a surface. Okay, that's usually width or length, right? But we have to imagine that we're going to tip this right rectangular prism over on its base, and if we do that, we will then have the height of 6.5 meters, okay? So if we go ahead and multiply that, what we've done here is we've actually kind of sectioned this right triangular prism into 6.5 sections of base, okay? So we've taken that base, which was 1 meter squared, and we've multiplied it by 6.5. So we've taken like 6.5 of those sections, okay? And that equals 6.5 meters cubed, okay? So 6.5 cubic meters, and hopefully you got this. You might have gotten this. I'm very, very proud of you if you did, and not at all upset if you didn't, because this is a process and it takes some time, okay? And there we go. Same idea there. All right, so here we go. Let's move on to our next. Now here we have a right pentagonal prism, and it is composed of a right rectangular prism joined with a right triangular prism. And your challenge here is to find the volume of the right pentagonal prism shown in the diagram using two different strategies. So firstly, here's where this idea of a pentagonal prism here, because we have 1, 2, 3, 4, 5 sides. Okay, so if you look at the face of a house, or, well, not a house really, but a face of a shed of some sort, I wonder if you've ever thought of it as being a pentagonal, a pentagon, okay? But it is, and there it is, because it has 5 sides. Those 5 sides do not have to be equal, okay, to be a pentagon, all right? Anyway, yeah, let me get rid of that. Just wanted to show you there why this is a pentagonal prism. But as they've mentioned here, this pentagonal prism can be thought of as a composed, this idea of composition now. Right rectangular prism joined with a right triangular prism, okay? And I think I wrote that again. Okay. So what I want you to do is you want to give it a try. And they're asking for 2 different strategies, okay? If you want to do just one that you can think of offhand, just go ahead and do it with that one. Come on back and check it with me, and I will go over both strategies with you. Okay, welcome back. So here we go. Strategy 1. Okay, so strategy 1, we are going to take this this pentagonal prism, right pentagonal prism, and we're going to break it up into 2 parts. Okay, a rectangular prism and a triangular prism. So if you remember, we'll talk about it again at the end of the lesson, but we are decomposing, because if you remember in the original problem here, it said this right pentagonal prism is composed of a right triangular prism and a right rectangular prism. Well, now we're going to decompose it, and we're going to look at it as 2 different things, okay? 2 different things. So just remembering, now we have V, volume, equals the area of our base times the height, okay? So let's go ahead and work with the triangular prism first, okay? All right, so there we go. There we have it. Our first part there was 1/2 base times height, which was our triangle in the front, and then times the 6.5, which was our height, which really isn't height, but you know what I mean, that part right there. And this is exactly what we did already. Okay, we already did this just in the last exercise. So yeah, the total volume of that triangular prism, or right triangular prism, is 6.5 meters cubed. Okay, so if we look at the rectangular prism, again, volume equals base times height, area of the base times the height. And in this case, it's 4 times 6.5. Okay, so a rectangular prism, and again, this is our base right here. There's our 4, and here's our 6.5, which is going to be the same there. Okay, so 4 times 6.5, and then we're going to multiply that all by the height, again, this strange height which moves along the ground, okay, which is 6.5. Okay, so I just did that again, and we'll get that. Okay, so we get 4 times 6.5 is 26, so that's actually the area of our rectangular prism is 26 square units, or sorry, we have square meters, and then times 6.5 meters, which equals 169 cubic meters. Okay, so now we have these two, and what we're going to do with those two is we're going to add them together, of course, and if we add that 6.5 cubic meters plus 169 cubic meters, we get a total of 175.5 cubic meters is the area of that right pentagonal prism, okay, and we've used the strategy of decomposition, okay, taking it apart. Alrighty? Okay, so let's look at strategy 2. Strategy 2, a little bit different, using same values, but a little bit different. In this case, we're going to look at not the volume of the right rectangular prism and the right triangular prism and then add them. We're going to actually find out first we're going to find out the area of that triangle. Then we're going to find out that area of that rectangle. Okay, and we're going to add those together. And then we're going to multiply all of that by the height, okay? By the height of the right pentagonal prism, okay? So let's go ahead and do that. Okay, and again, we have our area of our triangle, which we know is 1/2 base times height. So 1/2, 4 times 1/2, and 1/2 of 2 is 1. So we have 1 meter squared for the area of the triangular base there. Okay, and then area of a rectangle is very simple. Of course, it's base times height, and that's going to be 4 times 6.5, which is 26 meters squared. Okay, add those together, you get 27 meters squared. So now we have the area of that pentagon, actually. So we have an area of this this pentagon right here. Let me just go ahead and draw that in. So we've actually calculated the area of this whole pentagon. Okay, right there, that pentagon. We've got the area there. Okay, and now we're just going to multiply that by the height, which is 6.5 meters. Okay, and if we multiply that by the height, 27 meters squared times 6.5 meters, we get 175.5 cubic meters. And maybe some of you did it this way. If not, welcome to strategy 2. You could use either one of those because they are both very conceptually correct. Okay, and whichever one you may find easier, go ahead. I mean, in truth, maybe this is easier, this strategy, because you just get the area, which is pretty simple, and then just multiply it by that height number. Okay, and again, like we had done before, what we've done with this is as well. We've found the area of one section of the flat face of this, or the base of this pentagonal prism, and then we've multiplied it by the height. We've cut it into pieces, 6.5 meter high pieces, and yeah, that's what we've done there. All right, and believe it or not, it's 33 minutes and 58 seconds, and we are in our closing phase, okay? So here we go with our closing. So we've looked at strategies to use to find volume of 3D or three-dimensional objects, okay? And I'd like you to write these down somewhere if you have some room there on your binder pages. I'd like you to put these in there. So first we looked at find the area. Well, no, we didn't do this first, actually. We did this second. This was our strategy number 2, but I'm going to talk about it first. We found the area of the figure's base, and again, 3 lines under that base, because we're going to talk about the base and how we decide what exactly the base of a 3D figure is. again, I've kind of talked about it already, but we'll continue to talk about it because it is of extreme importance. Okay. Then we multiply by its height. Okay, so we find the area of the figure's base, which we just did, and then we multiply by its height. So we're doing this. We have area of that triangle, area of that rectangle, and then we multiply by the height. Okay, again, that height idea. You've got to actually change your idea of what height is. Truly, the reason they put these figures like this, or they draw them like this with the height going along the bottom, is that it's easier to actually label the triangle and the rectangle there. Okay, but it can be quite confusing. And again, 6.5 levels or 6.5 pieces of that area. Okay, we've taken that area and then we've just multiplied it by 6.5 levels of it, because that's 6.5 meters high, quote unquote high. Okay. Okay, so a second strategy, which was the first thing we did last time with our previous example, was to decompose. Again, a word we've used before and we'll continue to use. Decompose the prism. Again, we're trying to make this all easier. Okay, that's the strategy here. Math seems very, very complex to many people, but the truth is math is continually trying to make things easier. That is the absolute goal of all that we're doing here. So decompose the prism into 2 or more smaller prisms of the same height, and that is really important. It's underlined 3 times there each, because the same height, very, very important aspect. Okay, and then we add those volumes. Okay, and if we did that, we find the volume, number 1, volume of that right triangular prism, and then the volume of that right rectangular prism, and then we add those 2 up. Okay, so one more important point. Okay, important point is how, and again the question is, how do you determine which face to use as the base? Which face is the base? Okay, and we've talked about it before. Prisms, when they give you the name of the prism, you know the name of that prism is going to be the base. Okay, if it's a triangular prism, the triangle is the base. If it's a pentagonal prism, the pentagon is the base. If it's a hexagonal prism, the hexagon is the base. Okay, and here is actually a picture, and again, this is that's a hexagon. Okay, you can see it's a hexagonal prism because it is six-sided. Okay, your first this is actually your exit ticket, which looks like this. Okay, and they're going to ask you to find the volume of this hexagonal prism. And the base, which is the base, and of course I think you might know already, the base is going to be that hexagon. Okay, choose the height. Okay, so if you look at the height of this, and you can see that it is that 3 inches, and it is consistent. Okay, it is consistent. It can be sliced into equal pieces. Okay, like that, etc. Okay, so the reason, okay, we do it this way, again, we can choose the base just based on the fact that, actually, I'm not sure in this exit ticket they even call, oh no, they do. Okay, they do call it a hexagon. All right, but again, you can see that that is a hexagon right there. It's a hexagonal prism, so you know that that is going to be your base. And then this is going to be your height right there, the 3 inches, okay? But again, the reason is you need a consistent measure that you can actually slice into equal pieces, okay? Just like this, and multiply by your height, okay? And that will give you your volume. Okay, well, I think that is it. I'm going to talk until the clock strikes 40, okay, 40 minutes. hope this gives you some good time to finish your exit tickets and problem sets without getting too stressed. Okay, see you soon.